Okay, in the previous video, the first video, we showed how to write the half reactions for a given redox reaction. First, we had to figure out whether the reaction was a redox reaction by seeing if oxidation numbers changed. Then we wrote the half reactions. And at the end of the video, I said some reactions require the electrons being balanced to make sure that the reaction is conserving the law of conservation of mass and the law of conservation of charge. In this video, I'm going to show just what I mean by that. So here, I'm going to balancing half reactions. So as an example, let's take aluminum solid plus copper 2 nitrate. And remember, redox reactions occur in solution, so it's in water, giving you aluminum nitrate plus aluminum solid plus copper 2 nitrate in solution, giving you aluminum nitrate plus copper solid. Alright, so this is the starting equation. Now let's get the half reactions. If we look, we notice that aluminum goes from 0 to +3. Copper goes from +2 to 0, because remember, the free state is 0 for any element. And when it's in a compound, it's obviously not going to be 0. Copper is +2 here, it's +3 here. You get that by reverse crisscrossing. Now here's a trick. Polyatomic ions don't change. Alright, since they are not messed with in a reaction, you don't have to worry about the oxidation numbers for the N or the O3 here, because they don't change. In this case, O is always going to be -2 for the nitrate ion, and N is going to be -6. N is always going to be +5. Check this yourself, but it never changes. This is +5 here before the reaction, this is +5 here after the reaction. This is -2 for each O before the reaction. This is -2 for each O before the reaction. So, aluminum went from 0 to +3, and copper went from +2 to 0. Therefore, aluminum is undergoing oxidation Therefore, aluminum, is going through oxidation, and copper is going through reduction. So, we can write these reactions. The oxidation half reaction is Al0 solid going to Al3+ aqueous. But remember, we have to include 3 electrons to conserve the law of conservation of charge. We have 1Al, 1Al. Oh, again, I forgot. Check if the equation is balanced. No, the equation is not balanced. We have 1Al, 1Al, 1Cu, 1Cu, 2 NO3s, 3 NO3s. So we need a 2 here, which means we need a 2 here. And now we have 6 NO3s, which means we need 6 NO3s. So we have a 3 here, and therefore we have a 3 here. Now this, what I did here, made sure that the equation is balanced. But ignore what I just did. Let's get the oxidation half reaction. Alright. The oxidation half reaction is Al0 to Al3+ plus 3 electrons, and the reduction half reaction is Cu2+ aqueous going to Cu solid. But remember, it had to gain electrons to do that. So to go from +2 to 0, it's got to gain 2 electrons. But look what we have here. In the oxidation reaction, we have 3 electrons on the right. In the reduction reaction, we have 2 electrons on the left. If you add these 2 up, you get 1 extra electron on the right side. This cannot happen. So what do we need to do? We need to scale the top reaction and the bottom reaction by a certain amount so that the electrons cancel out. Because remember, if some substance gains electrons, another substance must give those electrons the same amount. So if one substance gained 5 electrons, some other substance must give 5 electrons. Can't be less, can't be more. It's got to have the same amount. So we have to scale these 2 reactions up so that the number of electrons being given by oxidation is equal to the number of electrons gained by reduction. So what do? We notice 3 and we notice 2. The obvious answer, if you think about it, is to scale this reaction up by 2 and to scale this reaction up by 3. Doing so makes you have 2 times 3, 6 electrons on the right, and 3 times 2, 6 electrons on the left. That will cancel each other out. And by the way, what I did here is get the coefficients for the balanced equation. Alright, you could have easily done the balanced equation without doing redox calculations here. But it turns out doing the half reactions, scaling it up, and then adding the net reactions will give you the coefficients of a balanced equation, as I'm about to show you. So, here's the net reaction. The net reaction for this oxidation reduction half reaction, the net reaction, just add them up. 2Al solid plus 3Cu2 plus aqueous plus 3 times 2, don't forget to multiply, 6 electrons, arrow, 2 times Al3 plus gives you 2 Al3 plus aqueous plus 2 times 3, 6 electrons, plus 3 times Cu solid, 3 Cu solid. Is this done? Are we done? Well, we have 2 Als before the reaction, 2 Als after the reaction, 3 Cus before the reaction, 3 Cus after the reaction, 6 electrons before, 6 electrons after. These electrons cancel out, as they must, because it's a redox reaction. The aluminum gives 6 electrons to the copper ions, thereby creating the redox reaction. So this is what we get. Oh, and my careless mistake turns out to be validated by what we did here. 2 Als, 2 Als. 3 Cus, 3 Cus in front of that compound. Remember here, nitrate is a spectator ion. It doesn't do anything. 2 Als, 2 Als. 6 electrons cancel out. 3 Cus, 3 Cus. So, using the oxidation reduction half reaction, we not only get the half reactions, but apparently, which obviously we should realize, we get the coefficients for the overall equation as well, if we forgot to balance the equation. Alright, that's the end of this video.